Welcome to Defense Cassette. I'm Sonal, your defense anchor. Hope you will enjoy this video. In a recent media interaction, Atul Dinkarain, the CEO and MD of Brahmos Aerospace, made a significant statement, ruling out the possibility of equipping the Brahmos supersonic cruise missile with a nuclear warhead. The decision comes as India reaffirms its commitment to conventional warfare and clarifies its stance on the deployment of nuclear weapons. Concerns were raised when the missile was accidentally fired from Sirsa, Haryana, in 2022 and crashed into Mian Chanu, Karnewal district, Punjab, Pakistan. Pakistan swiftly claimed that the Brahmos missile could have triggered a nuclear incident, given its potential to be armed with nuclear warheads. Rain, in his recent statement, debunked these claims and set the record straight. He clarified that the Brahmos missile has a maximum capacity to carry a warhead of 300 kilograms, which, in theory, could be used for equipping it with a tactical nuclear weapon. However, he emphasized that India has not pursued the development of tactical nuclear weapons for deployment on the Brahmos or any other subsonic cruise missiles. Unlike Pakistan, which has invested in the development of tactical nuclear weapons for its Baba missile, India has chosen to focus solely on conventional capabilities. For its Brahmos missile, by opting for conventional warheads, India aims to avoid any miscalculation and maintain transparency while employing the weapon during conflict. Argentina is keen to acquire 15 to 16 Tejas fighters directly from India, and it also aims to assemble an additional 30 jets locally in its own country. This proposition opens up significant avenues for collaboration, technology transfer, and joint production, further fostering a robust defense relationship between the two nations. To sweeten the deal, India has offered to equip the Tejas Mk1A with either American or Russian ejection seats, providing Argentina with a range of options to suit its requirements and preferences. Additionally, India is willing to replace the UK-supplied nose cone with a locally manufactured alternative, showcasing India's commitment to self-reliance and indigenous production. Moreover, India's proactive approach to modernizing its defense fleet is evident in its plans to replace the British Dunlop tyres currently used in the Tejas aircraft with domestically produced MRF tyres. This move not only emphasizes India's focus on self-sufficiency but also presents Argentina with the prospect of accessing cutting-edge technology and equipment for its fighter. MOD has taken significant steps towards enhancing its reconnaissance and surveillance capabilities by initiating a leasing project for 20 helicopters. With a focus on modernization and operational efficiency, the MOD aims to procure these helicopters to support vital missions while also ensuring long-term maintenance and training support. The Request for Information (RFI) released on Wednesday invites helicopter original equipment manufacturers or authorized Indian leasing firms to participate in the project, emphasizing compliance with the Defense Acquisition Procedure (DAP) 2020. The ministry's decision to lease helicopters comes in light of the ongoing challenges faced with previous procurement plans. The proposed Ka-226T procurement from Russia has experienced delays and is now unlikely to materialize. Simultaneously, the indigenous light utility helicopter (LUH) developed by HAL, while cleared for induction, awaits qualification of the autopilot system to become fully operational. These delays have prompted the MOD to explore leasing options to bridge the gap and bolster its operational readiness. The Request for Information seeks to lease 20 helicopters equipped for reconnaissance and surveillance operations. In addition to the helicopters, the lease will include essential ground support equipment, which is crucial for seamless operations and maintenance. The lessor will be responsible for providing comprehensive maintenance support, including performance-based logistics. The RFI specifically mentions that the lessor should demonstrate the ability to deliver all 20 helicopters within 2 years from the contract signing date. This requirement underlines the urgency to strengthen India's reconnaissance and surveillance capabilities promptly. Abyom Space Tech, India's pioneering space technology company, has marked a significant achievement with the successful low-pressure hot test of its 2.5 kN rocket engine. The company's cutting-edge engine, which is both reignitable and throttleable, has undergone a series of rigorous tests at its mobile engine test facility in Hyderabad, showcasing India's growing capabilities in space technology. The low-pressure hot test is a crucial phase in the development of rocket engines. It involves igniting the engine at reduced pressure conditions, simulating the initial stages of launch and assessing its performance under these critical circumstances. The successful completion of this test indicates that the engine's design and components are functioning as intended, paving the way for further testing and optimization. The reignitable and throttleable cryogenic rocket engine developed by Abyom Space Tech has a wide range of potential applications in the space industry. Its advanced capabilities could be utilized in satellite launches, orbital maneuvers, and deep space missions. ISRO successfully tested the Gaganyan Service Module propulsion system on July 19, 2023 at ISRO Propulsion Complex, Mahendragiri. This test involved 5 liquid apogee motor engines with a thrust of 440 N and 16 reaction control system, RCS thrusters with a thrust of 100 N. The service module of Gaganyan is a regulated by propellant-based propulsion system that caters to the requirements of the orbital module, performing orbit injection, circularization, on-orbit control, de-boost maneuvering and SM-based abort during the ascent phase. The 440 N thrust LAM engines provide the main propulsive force during the mission ascending phase, while the RCS thrusters ensure precise attitude correction. The hot test of the system demonstration model emulated the fluid circuit of the service module propulsion system, encompassing the propellant tank feed system, helium pressurization system, flight-qualified thrusters, and control components. The first hot test of the Phase 2 test series demonstrated the integrated performance of the Gaganyan service module propulsion system. The test, conducted for a duration of 250 seconds, involved LAM engines firing in continuous mode, along with RCS thrusters, adhering to the test profile. As part of the Phase 1 test series of SMSDM, ISRO had previously conducted 5 hot tests, totaling a duration of 2,750 seconds. The earlier phase involved 5 440 N LAM engines and 8 100 N RCS thrusters. For the Phase 2 test series, the current configuration includes the full configuration of 5 440 N LAM engines and 16 100 N RCS thrusters. The Gaganyan Service Module Propulsion System is designed, developed, and realized by Liquid Propulsion Systems Center (LPSC). With the successful completion of this hot test, the SMPS has advanced in demonstrating its integrated performance in the full configuration. Moving forward, ISRO has scheduled 5 additional tests to demonstrate both nominal and off-nominal mission scenarios, reinforcing the rigor of testing and the commitment to mission success. The groundbreaking collaboration, the Bhabha Atomic Research Center (BARC) and the Indian Space Research Organisation (ISRO) are set to revolutionize space exploration by jointly developing a cutting-edge nuclear thermal rocket engine. This technology holds the key to faster and safer interplanetary missions, reducing transit times and mitigating risks for astronauts. Conventional chemical propulsion systems, while reliable, have limitations when it comes to the energy required to propel spacecraft across vast cosmic distances. Nuclear thermal rocket engines, on the other hand, offer an innovative solution that promises to propel humanity deeper into the cosmos. The nuclear thermal rocket engine works on the principles of nuclear fission. A fission reactor generates an intense amount of heat, far surpassing any chemical energy source. This extreme heat is then transferred to a liquid propellant, which expands and gets exhausted through a nozzle, generating thrust to propel the spacecraft forward. This process allows for much faster transit times, effectively reducing the duration of interplanetary journeys and minimizing the time astronauts spend exposed to cosmic radiation and other hazards. The potential of nuclear thermal rocket technology has been recognized for decades, and the last significant tests were conducted by the United States more than 50 years ago under NASA's Nuclear Engine for Rocket Vehicle Application and rover projects. However, further development and refinement of this technology were limited due to various factors. As the development of nuclear thermal rocket engines progresses, it opens up a plethora of opportunities for ambitious interplanetary missions. Mars, Venus, and even outer planets like Jupiter and Saturn could become more accessible, potentially leading to unprecedented scientific discoveries and human exploration in the far reaches of our solar system. ISRO is also planning to develop methane-based engines, which are the best chemical engines known till now.